Test automation involves using a software tool to run tests repeatedly against an application to be tested. Automated testing is becoming more and more utilized in the software industry, and with good reason, because there's many advantages to test automation, and they're all related to the repeatability of the test and the speed at which those tests can be executed. For one, if you have automated tests, they can repeat it many times with no human intervention, which means that you can schedule them to run when you want. An automated test can be run in parallel, running the same test on many different hosts in parallel, which can significantly speed up the time it takes to run your tests. And running a test manually to humans is pretty brain-numbing, and bored humans tend to make mistakes. When you use automated testing, you know that that test is going to run exactly the same way every time it's run, with no human execution errors. Now, regression tests are used during software development to ensure that the new development on the application did not break what was already working on it before. When you use automated tests, you can do frequent runs of your regression test, which allows you to find the errors and the bugs as soon as they're introduced into the code base. This gives rapid feedback to your developers. They know what they changed that introduced that bug, so it's much faster for them to fix it. And they fix it as soon as it's introduced. All of this results in test automation giving you a lot of advantages for improving the long-term efficiency of your software programs. You can run your tests often with no human intervention, no human errors. You get your bug feedback very quickly, which allows your developers to quickly fix those bugs, all resulting in a much faster go-to-market time. So automated testing gives a very high return on your initial investment. Now, Selenium is one of the most popular automated testing suites for testing web applications. And there's several reasons for that. For one, it's open source. So there's not a whole lot of investment to get up to speed using it. And Selenium supports a wide array of different browsers running on many different platforms. And it supports multiple language bindings and can run within multiple testing frameworks. The Selenium project by itself alone supports the browsers Firefox, Internet Explorer, Safari, Opera, and Chrome, with language bindings for Java, C#, Ruby, Python, and JavaScript. And it runs on the Windows XP 7, 8, 8.1, and the Apple OS X, and the Linux platforms. However, Selenium also comes with a very large involved user base community, and they provide a lot of help through many different online groups and forums. This community also provides a number of third-party drivers, bindings, and plugins. And these third-party components expand the number of browsers that Selenium can support, as well as the add language bindings to support Perl, PHP, Objective-C, R, Dart, and even TCL. Now, Selenium is not a single test tool. Instead, it's composed of multiple software tools, and each has a specific role, a different approach to supporting test automation. Used alone or in conjunction with each other, the Selenium tools enable web application test automation, supporting many different test processes in many different types of test environments. Now, the suite of Selenium tools includes four: the Selenium IDE, Selenium RC, Selenium WebDriver, and Selenium Grid. Selenium IDE is the integrated development environment. It's the simplest and easiest of all the tools within the Selenium package. The IDE is a Firefox plugin GUI tool, which can be used to quickly prototype automated test scripts. You use its recording features to capture your user actions as you're performing them, and then use those to create a reusable script, where these actions can be executed later automatically. And you can do this all with no direct use of scripting or programming languages. The IDE also exposes the users to the Selenium commands, known as Selenese. These Selenium commands are used within the other test tools, so getting familiarity with them with the IDE will help you with the other tools as well. The Selenium IDE pros include that it's very easy to learn. This is because it uses common GUI controls to record your interactions with the web app and play them back. You don't need any programming knowledge. It gives you logging capabilities and the ability to set breakpoints. However, the Selenium IDE has some drawbacks. It's a Firefox plugin, so it doesn't support any other browsers besides Firefox. You have no support for any kind of control statements like loops or conditional if statements. There's no error handling, no database support, and there's no way to really organize your test scripts into groups or to understand the dependencies between different test scripts. Selenium RC works with a test client written in any programming language. The client talks to a separate Selenium server process, which communicates with the browser using a JavaScript Selenium core library. Selenium RC has a number of great features. It supports many versions of lots and lots of different browsers. It works with any programming language and allows user customization. RC also includes support for databases, error handling, logging, and screenshot captures. And it works with lots of different testing frameworks. However, Selenium RC is hampered by its separate Selenium server process, which has to be started manually in order to use it. And needing a separate server process causes inefficient handling of alerts, AJAX calls, and navigation. Also, the JavaScript library is restricted by browser security policies. And further, Selenium RC has no support for listeners or web applications. And you need programming experience to use it. Now, Selenium RC was the main Selenium tool for a long time, before WebDriver was introduced in Selenium 2.0. Selenium WebDriver offers an object-oriented API, listeners, and dynamic finders. It also supports testing web applications and gives us enhanced processing of alerts, navigations, AJAX, and dropdowns. WebDriver is also quite a bit faster than Selenium RC. And the WebDriver list of cons is pretty short. It has a more complex API, because of course it offers a lot more features, and you need object-oriented programming knowledge in order to use its library. And there's no support for mobile testing or Flash objects. Selenium Grid is the last tool in the Selenium testing tool suite. It is used to support parallel testing on multiple platforms and browsers simultaneously. So you want to use the Selenium Grid to support large test suites or run in multiple distributed test execution environments. Selenium Grid can significantly cut the amount of time it takes to run large or slow-running test suites, because you can divide those test suites up into smaller groups of tests and run them in parallel on different machines. You can also use it to run the same test on lots of different hosts in parallel, testing different environments, browsers, and operating systems all at the same time. To understand Selenium 2.0, we need to understand the Selenium 1 architecture that preceded it, namely the Selenium RC, or remote control server. Selenium 1 is composed of 3 components, each running in a separate process. You have the Selenium client libraries running the client test application, the Selenium remote control server that runs as a standalone process, and the Selenium core JavaScript functions, which run inside the browser. Talking first about the Selenium client libraries, there's a different client library for every programming language that's supported by Selenium. The client library provides an API to the client test application, which it uses to control the application under test. The client library is going to accept requests from the client application, turn them into the Selenium commands, and send it as an HTTP GET or POST request to the Selenium RC server. The Selenium RC is a standalone process, and it controls launching and shutting down the browser, as well as controlling the application under test with Selenium commands. It's going to accept the Selenium command from the test client and apply them to the application running in the browser using the Selenium core. The Selenium core is a collection of JavaScript functions, which are injected into the browser process when the Selenium RC opens the browser for the first time. Now, the Selenium core functions execute Selenium commands using the browser's built-in JavaScript interpreter, which allows it to control the application under test. The results of the Selenium command that it executes is passed back through the Selenium RC to the Selenium client library, and finally to the client test application. Now, Selenium 1 gained great popularity due to its flexibility and extensibility, working with any browser and any programming language. However, requiring a separate server process complicated the architecture and slowed down testing. Additionally, browsers have JavaScript security limitations, which hampered the Selenium core capabilities. And the more new features offered by the browser for the web apps, the more restricted this JavaScript sandbox became. So WebDriver was developed to solve the Selenium 1 shortcomings. WebDriver is a testing tool that speaks directly to the browser using the browser's native API. In 2008, the existing Selenium merged with WebDriver to become Selenium 2.0. Selenium upgraded the Selenium grid, bundling the Selenium RC into the tool as the Selenium server. But by far, Selenium 2.0's biggest feature was integrating the WebDriver API into the product. While the Selenium RC talked to each browser the same way, by invoking injected JavaScript functions to drive the application, WebDriver allows the test application to talk directly to the browser using the browser's native API. And WebDriver's clean, object-oriented API provides support for many of the new web app features Selenium RC could not handle. For instance, it includes the dynamic finder objects, which support dynamic web pages, where elements of the page may change without the page itself being reloaded. WebDriver is also much faster than Selenium RC. In fact, the Selenium RC server is no longer needed if you're using the WebDriver API with your browser and test running on the same machine. Selenium RC is now deprecated and is not actively supported except for maintenance mode and for backward compatibility, though it still does have its uses in the Selenium 2 suite when using the Selenium WebDriver. You're going to use the Selenium RC, now known as the Selenium server, if you're using Selenium Grid to distribute your test over multiple hosts. You'll also use it if the browser you're controlling is on a remote machine, or if you want to use the HTML unit driver, which drives the headless HTML web browser, and you are not using the Selenium Java bindings in your application at that time. You can download all the tools in the Selenium test suite from the Selenium HQ download page that's shown here. Now, this rather long web page is broken up into sections where you can get the latest version of the tools as well as access some documentation. From here, you can download the Selenium server, which is a bundle of both the Selenium RC and Selenium Grid. You can get the client application libraries. These are required to use WebDriver or to talk with the Selenium server. And the Selenium IDE is also on this page, along with a long list of IDE plugins that you can install to extend the IDE's capabilities. And you can download the Selenium provided web drivers, which are required to use WebDriver with a web browser other than Firefox. Remember that WebDriver talks directly to the browser in the browser's native API. So each browser must have a driver that translates the WebDriver Selenium commands into commands the browser can natively understand. The download page also includes links to third-party WebDrivers, language bindings, and plugins that are not developed by Selenium HQ. The Selenium IDE is an easy-to-use Firefox plugin. The only requirement is you must have Mozilla Firefox installed. And installation is very easy. You start up the Firefox browser, navigate to the Selenium download page, find the Selenium IDE plugin selection, and click on the release version you want. You respond to the installation pop-up windows and then restart Firefox. After it's restarted, the Selenium IDE will appear under the Tools menu bar and under Web Developer Selenium IDE. You can also start it with the shortcut Ctrl-Alt-S. To use the Selenium WebDriver, or RC server, you must install the Selenium libraries. You download the libraries for the programming language your client application is using. Now each library is going to include both the WebDriver APIs and the APIs to interact with the Selenium RC server. Once downloaded, add the library to your client test application project in order to use the Selenium features. How you configure your application to use the libraries depends on your application's programming language and your development environment. For Java, the easiest way is to use Maven to download the Java jars, bindings, and dependencies. For C#, add the downloaded set of signed Selenium DLLs to your project. For Python, run pip install Selenium, and if you're using Ruby, install the Selenium gem, which is named Selenium-WebDriver. Now for Perl, PHP, and other language bindings that are provided by one or more third parties, you'll want to use the instructions for the third-party language bindings that you downloaded. To use the Selenium RC server or the Selenium grid, you must install the Selenium server. Selenium server bundles both the Selenium RC and Selenium grid into the same tool. Now Selenium server is a Java application, so you must have Java 1.5 or later installed. The Java Selenium server works with any of the client language bindings that you use in your client application, no matter which language. This is because they talk to each other with the HTTP request-response messaging. Selenium server downloads as a zip file that contains all the Selenium server jar files you need. Simply unzip it into any directory where it's accessible to Java. Now remember, you must manually start the Selenium server before running any test. To do this, you'll need Java installed and the path environment variable configured. Then you can run the Selenium server from the console or a command prompt. Selenium server has a number of parameters you can use when starting it up, and they'll change its mode, behavior, and configuration. For instance, you can use the startup parameters to make the Selenium server run as a standalone server or as a Selenium grid node or hub. So once you figure out the startup parameters you need, you might want to create a script or shortcut, depending on your platform, to bring up the Selenium server with the configuration you want it to run under. Okay, here we are on the Selenium headquarters website, and we're on their download page. There's the URL on the download tab, and from this page we can download any of the Selenium tools and the plugins and the third-party extensions. And there's quite a few other tabs here. You can see the support tab is a nice one to know about because it gives you access to the Selenium user community through the chats, the forums, the user groups, and also the bug tracker. And coming down here, if you are a Java user, you want to click on this Maven user link because that's going to show you the location of the Maven repository that houses the Selenium jars. And it's also going to show you how to configure your dependency elements in order to bring Selenium into your Maven project. Here is the section for our Selenium server, which is the bundling of the Selenium RC and the Selenium grid. And if you want to use it as the Selenium grid, you'll want to see this page because it tells you how to configure it and what the startup parameters are. Coming a little further down, Selenium HQ provides the web drivers for the Internet Explorer and the Safari browsers. Those are used by the web driver, since the web driver just sends Selenium commands, but it wants to talk natively to the browsers. These are the intermediate drivers that translate those Selenium commands into the native language of the Internet Explorer and the Safari. Then in this section, we have our Selenium client WebDriver language bindings. These are the libraries for different programming languages. And you can see you can download them. They each have a change log and also API documentation. Then we come to our third party, drivers, bindings, and plugins. These significantly extend the reach of the Selenium, the number of browsers it can use, the number of languages it can work with, and these are provided by third parties. They're not developed by Selenium HQ. So here we see the drivers and all the different browsers, and then further down, these are the languages that are provided by third parties. So if you're using any of these languages, this is where you would go to get your language libraries. Now, the Selenium grid is extendable with plugins, and here's a couple of plugins that you could download and use if you'd like. And then we have the Selenium IDE. Now, the Selenium IDE is also configurable with plugins. And on this page, we have pages and pages and pages of Selenium IDE plugins. So you can explore those at your leisure. What we're going to be doing now is we're actually going to be installing the Selenium IDE, just so you can see how easy it is. We're going to be installing version 2.9, and the first thing you have to do is we're in Firefox. You can see we're in Firefox. You need to have the Firefox browser that you're using because that's the only browser that the Selenium IDE will work with. So you simply click on it. Firefox wants you to be safe, so it's going to say, do you want to download this? Say allow it. And then it'll come up with the plugins that are associated with Selenium. Install them, and then it's going to ask you to restart. So once it restarts, then Selenium will be installed. So here we're back, and you go to Tools, and you can see Selenium IDE is right there, or you can go under Web Developer, there's Selenium IDE, or you can use Control-Alt-S. So once I click on it, it's going to come up, and here is the Selenium IDE tool, all ready for us to start interacting with our web page, recording our commands to create our test scripts. Selenium commands, often called Selenese, are the set of commands you use to create your test scripts. Selenium offers a rich domain of commands for exercising and inspecting a web page. Now, the same commands are used in the IDE, WebDriver, and RC tools. So learning the Selenese syntax and format will benefit you across all the Selenium tools. Now, here's the URL where you'll find the full Selenium command reference. There are three types of Selenium commands: actions, accessors, and assertions. Actions exercise the web page. These commands do things like navigate to URLs, click buttons, or type input into text fields. If an action fails, the test script's going to stop and report the failure. Accessors find elements on the page and retrieve their value for the test application to use. This could include values such as the contents of a text box or the title of the web page. Now, assertions also find elements and retrieve their value, but they also check that value against an expected result. An assertion fails if the expected result does not match the value retrieved from the web page. There are three types of assertions: assert, verify, and wait for, and each has a different fail behavior. If an assert fails, The test stops and reports the failure. While if a verify fails, it's logged, but the test continues. And the wait for will wait for the web page to reach a condition or state, like a page being loaded. And if the condition does not happen within a timeout period, the test is stopped and a failure is logged. Some common Selenese commands include open, to navigate to a page in the browser using the page's URL, click, to perform a click operation like clicking a button, selecting a radio button, or picking an item from the select pull-down menu, verify, which tells you if the expected page element is on the current page. Now that page element could be a page title, text string, or some other UI element. And wait, which pauses execution until an expected page is loaded or an expected UI element is present on the page. Now many Selenium action commands have a version with a wait for or and wait suffix. One example is the command click, which also has a click and wait version. While the regular version of the command does its action, then continues on immediately, and wait commands do the action, then wait for the page to load before continuing. So you always want to use the and wait version of a Selenium command when the action causes the application to request information from the server, either to navigate to a new page or refresh the current page. Now do not use the and wait version if the action will not trigger a navigation or refresh. Doing so will cause Selenium to wait for the new page information until it times out, which will fail your test. The wait for command suffix allows you to wait until a specified element is visible, present, or active. If the specified timeout period elapses without the wait for condition being met, the test is going to fail. Wait for commands allow you to avoid hard coding the time to wait for a condition to happen. This is because during heavy system load, a hard-coded timeout may not be long enough, causing an unneeded failure. While if the system responds quickly, the time left to wait is just wasted time. Selenium commands have three parts: the command itself and two parameters which are optional. The first optional parameter is the target of the command. It will be a Selenium locator used to find a UI element on the page. The second parameter is a value or a text pattern. It is used as the expected result for an assertion or as the input for a field or selector on the page. Here in our table, each row represents a different command. The first command, open, has a target, download, but it doesn't have a value because all it needs is the target of the page it wants to open. Our second command, assert title, doesn't have a target because the target's going to be the title of the page. But it does have a value, download, which it's going to check to make sure the title matches. And our third command, type, takes both commands. It's going to look for an element. It's going to look for a text box that has ID search text, and then it's going to type the value Selenium into that text box. In the Selenium IDE tool, the commands that make up each test script are stored in a text file, and that defaults to the HTML format. So if you look at your test script files, you'll see the Selenium commands are stored in an HTML table with 3 columns. Each row of the table is a different command. And in each row, column 1 is the Selenium command, column 2 holds the target of the command, and column 3 contains a value to apply to the target. If the command does not take both parameters, the column must still be present in the HTML table. It will just have an empty value. So here we have our 3 commands again. You can see in the first row, the first column is our command open, the second column is our target, download, and the third column is empty because we don't have a value. The second row has our assert title as the command. There is no target, so that column is empty, but the third column holds the value that we want to assert against the title of the web page, downloads. The third row has our type command, and it has both parameters. ID search text will find the page element that's the target of what we want to type. And then the third value And then the third column has Selenium, which is the value we want to type into that text box.